Hi, my name is Amanda Murphy. I'm in Clinical Pathology 1, summer semester 2021. And this is my avma task video number 2. The first portion that I'm going to be doing is focusing more on our blood clotting, coagulation, those types of things. So I'm going to be doing a fibrinogen assay. And so essentially what we're looking for is how much fibrin is located in the bloodstream for proper clotting. So just real quick, kind of some of what we're going to go ahead and need material-wise is a sample of EDTA blood here, as well as a couple of microhematocrit tubes, if you can see those, the clay for those, a refractometer, which I do have a couple of syringes here. I just find it easier to get the plasma out of the microhematocrit tubes with a little bit of help since they're so small. A timer, which I have here, as well as a calculator for calculating our totals at the end, and our stat spin with our attachment for spinning down those microhematocrit tubes. And over here I also have our water bath, which has been fluctuating between 57 and 57 and 59 degrees Celsius. I think in the book it states 58 degrees Celsius, but it kind of goes between the two. So we'll kind of go from there, I guess. So let's go ahead and get started. So first things first is filling up our microhematocrit tubes, same way as we would if we were doing like a PCV and whatnot. I think you should be able to see what I'm doing here. Maybe I can get it in there. Alright, we're filling up. And I do want to go about 3/4 of the way. I guess in one I got a little bit higher than that. So I'm just going to go ahead and do the other one. See if I can't level it out a little bit more. That looks about good. So from there, I probably should be wearing gloves doing this. But I'm going to go ahead and just plop this in my clay just to, close off one end so that when we're spinning we don't lose everything at the end. And then I am going to place these inside of our attachment here, and I do want to put these in there with the clay facing outwards and balanced, and then we'll just go ahead and close this, stick this over here on our machine. We do want to make sure that it is set on microhematocrit, which is where I have it set. Make sure our lid is good and closed, and press start. Once this is done spinning, we'll go ahead, come back, and continue the rest of the test. Alright, so it's just finishing up its spinning here. So what we're going to go ahead and do is just take this out. And when taking this out, so I'm going to go ahead and start incubating my one tube. So we do want to incubate one tube in our water bath for 3 minutes. So I'm just going to come over here to our water bath real quick. I do have a tube in here, just a white top tube that has water in it that's been incubating. And just to kind of show you, I think right now we're at 57, just a second ago it was 58, 59. But I do have, I did have this incubating. I just find that it's a little bit easier to fish out my tube when the time is up, as opposed to throwing the whole thing in the big water bath. So I'm just going to go ahead and toss this in here, plop my lid back on, and then throw it in my water bath and set my timer for my 3 minutes and let that start. Now I'm going to go ahead and work on my other tube here. So I'm just going to bring you down here a little bit with me, hopefully. Oh, okay, we're really coming down here. All right. So all we're going to do is test total solids like we would normally with our PCV total solids. So I'm just going to break this right here. as you can see. And then this is where my my syringe kind of comes in handy. I just take this and go ahead, insert it into the top part of that tube where there isn't any plasma, and push some of that air out, or air through it to give me enough sample to actually read. All right, and now we will go ahead and read our sample. And let me just all right, and so with our sample, looking up here, reading on the plasma protein side, I have looks like 8.5 grams per 100 milliliters. So I'm just going to write that number down because we will use it, 8.9 grams per deciliter. We will use that later in our determining kind of how much fibrin is located in the blood. Get rid of this needle. So what we end up doing is as this is incubating, the fibrin is actually evaporated from the sample. So once this is done incubating, we'll spin it down again, and then we will do another total solid reading off of that tube, and then subtract that from our initial reading, which is going to kind of show us the difference between how much fibrinogen was in there versus what was evaporated out, hence being a guesstimate on, you know, what we have within the bloodstream, more or less. So we're just going to wait another 30 seconds. All right, and there's our timer. So we're just going to pull our tube out here, and I'm just going to dump out my water. I don't really need that anymore, and hopefully be able to get my tube here. All right, there we go. And so I've taken my tube out of the incubation, and I'm just going to place it back into my stat spin. I should be able to spin this without a balance, I'm hoping. No. I've done it before, and it seems to do okay. So we'll just take this, put it back over here in our stat spin here, and go ahead and press start. And then once that has finished spinning, we will come back and do the rest of our test. All right, so we are just now finishing up here. So we'll go ahead and take this out. Come back around to me here. All right. And one of the things that I didn't mention is you do want to make sure that you clean your refractometer in between. You don't want to get any false readings. I did that with a little bit of distilled water and some Kimtech paper. Just kind of rinsed it off so that I no longer have any other sample in there to contaminate it or give me false readings. All right, we'll go ahead and come back on down here to our little spot. And once again, we are just going to, now that it is spun, incubated and spun, our fibrin should be evaporated. So we're just going to go ahead and break this like we normally would. Break it a little bit farther up because I got some blood there. All right. And I'm just going to once again use my needle to help me out here, and I do my best not to actually touch the plasma because I don't want it to suck up into my needle. All right, it doesn't take much. That should be enough to give me a reading here. So we're just going to pop our lid back on and come up here. Oops, sorry, and read. All right. it is looking like we are at 7.5. So 7.5 grams per deciliter. So our next step from there, as you can see, I have 8.9 grams per deciliter minus 7.5 grams per deciliter. So we will just go ahead and do that math real quick, and I will use the calculator just to make sure my math is correct. So that is 1.4 grams per deciliter, but we do want to give our results in milligrams per deciliter. So we're just going to go ahead and take that amount, that 1.4, and times that by 1,000, which gives us 1,400 milligrams per deciliter. Our normal amounts, I believe, for a dog with what I'm doing are anywhere from 1.3 grams per deciliter to 4.3 or 4.8 grams per deciliter is I believe what it is, or that would be 1,300 milligrams or 4,800 milligrams per deciliter is our normal range. So we would still be in that normal range here at 1.4 grams per deciliter or 1,400 milligrams per deciliter. So our patient is within normal ranges. So that is how you do a fibrinogen assay. All right, so for the blood chemistry portion of the video, I am going to be doing a blood glucose. So for that, we just need a blood glucometer here, or just a glucometer, test strip here that goes into it, as well as our sample of blood, which I have here. We don't need too much. I just used for my patient not too long ago. So all we're going to go ahead and do is we're going to take our test strip, insert it into the bottom here. I'll kind of let you see this. So we have the little hourglass, and then it says that it's ready for the drop of blood. So I'm just going to go ahead and take my needle off here. Make sure we're good in here towards the end. And all I'm going to do is there's a little spot, I don't know if you can see it, that like yellow gold area. And that's just where we are going to put our blood onto there. And then it should start to read. All right, so blood glucose is 70. Typically, this is on a cat, so typically we would be between 80 and 120 for our normal blood glucose levels. So this is a little low, but that is essentially how you perform a blood glucose. All right, so I'm going to be walking you through a serological test. I'm going to be doing an FeLV-FIV witness test here. So it does state that you can either use whole blood unclotted through EDTA or heparin, as well as serum or plasma. So today we are going to be using, I do have a sample here from my patient of an unclotted EDTA sample. Materials that you'll need would be your sample here, your test itself. I do have my buffer, as well as an eyedropper just to go ahead and, or a pipette just to go ahead and take my sample and get that here onto my test. So I'm just going to go ahead and drop this down here real quick and just kind of show you what we do. All right. So to go ahead and perform this test, I'm just going to go ahead, open up my sample. I do need 1 drop of blood in each bay, as well as 2 drops of our buffer here. Let's see, make sure you can see that. All right. So we have 1 drop in each tube. Go ahead and set this down here. And then I am just going to go ahead and I'll let you kind of see this a little bit clearer here. Maybe we can get in here. All right, there we go. And so we've got 1, 2, 1, 2. All right, and then we go ahead and we just kind of let that, I guess, wick on down. We do set our timer for 10 minutes. And after 10 minutes has completed, which I am going to set that here on my watch, we will come back, and that's when we can go ahead and take a look at our results on whether or not our kitty is positive for FELV or FIV. So I will go ahead and just kind of let you see the wicking process here real quick as it's coming down, so you can see that it is moving. And then we'll go ahead and read that here in about another 10 minutes. All right, so it has been 10 minutes. And our test is complete. So our little kitten here is negative. You can see here, this is our control line. If we did have any lines up here, a second one that would be positive for either one. So this is the FELV, we are negative. And the FIV, we are also negative. So we can go ahead and go let mom know that kitten is negative for these things and should just get a vaccine. So that is how you perform a serological FELV, FIV witness test. And we did use, as I said before, the whole blood EDTA unclotted sample here. Instead of the serum or plasma that can also be used to perform these tests. And that's it. All right, so I'm going to be walking you through how to perform a direct smear or direct drop heartworm test, or we're looking for microfilaria. So what we're going to go ahead and need for that is we are going to go ahead and need a slide cover, a sample of EDTA blood here, as well as something to go ahead and place our drop onto our slide. So I'm just going to kind of bring you down here with me. All right, in hopes that you can sort of see what I'm doing here. All right, well that is really far, but we'll work with it. So we're going to go ahead and take our sample here, pop the top off. I'm just going to take out, I just need one drop of blood here, and I'm just going to place it onto my slide like so. Go ahead and put this back together. Ooh. Put it back together, maybe not fill our whole sample. And then I am going to go ahead and take one of my cover slides here, and I'm just going to go ahead and place that down onto my slide, and then from there we will go ahead and come on over to our microscope here. And what we're going to go ahead and do while observing for this is we're obviously looking for microfilaria, looking for positive heartworm test. But the goal is to go ahead and we are going to look at it under a 10-time magnification to kind of see if anything's present. So I'm going to get us started there. All right. Blind myself. Let's get us all focused in here. All right, that's 30 and 10. All right, and so on the 10 times magnification, which I have it on here, what we're looking for is any form of like a movement with the red blood cells and things like that, trying to see the microfilaria, which kind of come up a little clear in this. So the easiest way to detect that is with movement. One of the things that I could have done is added a drop of saline to kind of disperse things a little bit for me. And spread those red blood cells out to make it a little bit easier to see. But we're also, one of the things that we can get confused with microfilaria is the I believe I said that. I don't think I said that right at all. But that is another microfilaria that we can see in the bloodstream. It's not really something that we're usually too concerned about with dogs, but it is there, and typically we determine that based on like the body size, the way that it's seen. Typically it's curved, as well as I believe it has a little bit more of a blunt head than the actual Dirofilaria imidis. So that's kind of what we're taking a look at. We want to go ahead and make sure that we are checking at least 10 fields for anything, and then if we do find something, we definitely want to either attempt to come across, if we can state how many are on the entire slide, awesome. If not, we want to, like kind of come up with an average or so to kind of get an idea of what we have. Yeah, so I'm not really, I don't really see anything on here. As far as I can see, it is negative. But that is how you perform a direct smear or direct drop heartworm test.